What's good, people? It's Chido back again with another reaction video. Today's video, I'll be reacting to a channel called The Impossible Build. I've reacted to a couple of videos from their channel in the past. They make really good videos, so I recommend you go check them out. I will leave the link to this video in the description down below. The title of this video is called Chimney Hollow Reservoir, Colorado's $500 million new mega dam. I think this is going to be interesting. I know that in Colorado they've been having a lot of heavy droughts in the last 20 years or so. So let's dive in and find out.
Colorado has experienced 17 drought years in the last 20 years, but the state is now working on one of the largest water infrastructure projects in history. A multi-million-dollar earthen dam reservoir with an insane capacity that could fill over 136,000 Olympic-sized swimming pools. In addition, the project is expected to preserve approximately 8.
Oh yes, so from the get-go, if I'm not mistaken, I think the last couple of dam videos that I reacted to were concrete dam structures. I think I reacted to a video about a dam in Pakistan, a double arch dam, which is a concrete structure, and this one, it's an earth embankment dam, which means it uses different materials and the dam profile is different as well. I think they will touch on those aspects in this video, and I will explain and add some of the information that I'm familiar with as the video progresses.
1,800 acres of wildlife habitat and maintained 29 aquatic habitat areas along the Colorado River while providing recreational opportunities. How will this project change the way we approach water conservation and management in Colorado and beyond? And what are the cutting-edge techniques involved? The story of this project is like something out of a Hollywood movie, but it is shockingly real. The Colorado River Basin is under a level of strain it hasn't experienced in more than a millennium, with drought driving supply down and population growth driving demand up. Scientists have outlined a grim future for the region, predicting that human-caused climate change will shrink the West's water supply. Colorado is built on a system of moving water around. About 80% of Colorado's water falls on the western slope of the Rocky Mountains, but about 80% of the state's 5.8 million people live east of the Rockies. For around 15 decades, those people have...
That's tough. That's a huge strain on a single river for such a population. I think it's an interstate river as well, so it crosses multiple states, and I'm sure they have an agreement on how they partition the water based on the use cases and how maybe the population of each and every state and what kind of economical activities that they use that water for. Yes, I don't know much about how the US water laws work, so if there's someone from the US who can give me like a brief explanation in the comment section below, I would really appreciate that.
Relied on a complex system of canals and tunnels that shuttle water across and through the mountains, often to reservoirs that store it for timed release. To put it simply, a reservoir was essential for water storage and is intended to supply water to the Northern Front Range, which includes the populous cities of Fort Collins, Greeley, and Longmont. The advent of the Chimney Hollow Reservoir project in this scene, surrounded by stunning mountains, stands as the best illustration of innovative water management. The reservoir's main purpose is to store water that is moved over the continental divide from the rain and snow-filled western slope. It will paint the bigger picture of creating a safe haven for a wide variety of wildlife while also providing supplemental water for more than 500,000 people in 8 communities around the area. However, hold off judgment until the true complexities are revealed. Building a reservoir involves far more than just gouging a hole in the ground. This project requires the construction of a massive dam.
It's interesting to see how the landscape changes in that time lapse, right? Like before, it was just a valley with some vegetation, and as time goes on and the construction proceeds, it starts to change, like the landscape. Sometimes unimaginable that in a couple of years, either side of this valley will be filled with water, and there will be different activities taking place, and a different landscape, different flora and fauna. Quite fascinating.
The construction of a massive dam, the tallest built in the United States in 25 years. The reservoir will require the removal of millions of cubic yards of earth. A whole dozen northeastern water companies in northeastern Colorado are funding Chimney Hollow Reservoir. Well, it looks justified because the reservoir will provide water and leisure to its communities after construction finishes in 2025. It will serve for 5 to 10 decades at least. In 2016, Stantec was hired to do geotechnical investigation and design for the Chimney Hollow project and is now providing engineering services during construction. Barnard is building the reservoir with a zoned rock-fill main dam, saddle dam, reinforced concrete inlet-outlet structure, spillway, concrete-lined tunnel, and water distribution facilities. Due to the absence of clay at the construction site, the asphalt core of the main dam had to be used. The Chimney Hollow main dam will be the second asphalt-cored dam in the U.S. after those in Europe and Canada. The site produces 63,000 tons of aggregate per day, making it Colorado's largest rock-fill mine. In this context, an earlier engineering achievement of significant...
This is interesting. So, basically, the implementation of asphalt in an earth embankment dam is to provide an impermeable layer at the central axis of the dam, right? Unlike a concrete dam structure where concrete is virtually impermeable, right? That's the whole idea of building a dam, so that you stop water from flowing across. But if it's an earth embankment dam, you use earth materials, right? So rocks, coarse aggregates, some boulders, and some fine aggregates. But then these are permeable materials. So if you don't have an impermeable layer at the central axis based on the design of the dam and the type of like the earth embankment dam that you are building, then the water will just flow through. And there's a risk as well, when the water is flowing through, it will create some channels, and that will lead to the destabilization of the whole structure and the collapse of the embankment dam. So in this case, they resorted to asphalt concrete as the central axis core rather than clay, which is another material that is used as well, because compacted stiff clay is impermeable, right? Because of just like the granular material and the consistency of clay particles. When they are wet and compacted, they stick together and they behave more like cement, right, when they are dry. But then it turns out that at this site, right, there was not enough clay materials to use that. So they resorted to using asphalt concrete, which serves the same purpose as using a clay central axis.
An earlier engineering achievement of significant importance comes into play. There was this Colorado Big Thompson project, which originated in the 1930s and was designed to redistribute water from the Colorado River on the western slope over the Continental Divide to communities on the eastern slope, including the Northern Front Range. You guessed right, the Chimney Hollow Reservoir is designed to store water from the Colorado Big Thompson project. This water is primarily from the western slope, where Colorado receives the vast majority of its rain and snow. It is carefully transported across the Continental Divide via a network of canals and tunnels, and then stored in the Chimney Hollow Reservoir until it is needed. The total cost of building the reservoir comes to about $500 million, making it...
Oh, this is interesting. I thought there was a river close by which was going to be feeding into this reservoir, but it turns out that they will be taking water from a different reservoir, then via some canals and tunnels, divert it and store it in the Chimney Hollow Reservoir for future use,
making it roughly $340,000 for each day of construction. Inarguably, some serious transactions are involved here. But wait, there are some statistics that are hard to digest. 90,000 acre-feet of water storage capacity, 4 million tons of aggregate processing, and 3.1 million cubic yards of excavation are being bragged here. Just imagine the size of an excavator at work that could dig the foundation of a house with just 3 scoops, and a waiting dump truck with tires twice the height of a person. The project managers are facing a challenge to place a whole load of rock on the dam every 2 minutes, 5 days a week for 2.5 years. At first glance, the giant reservoirs, dams, and river projects sprinkled across the United States might seem pretty similar. They hold back vast amounts of water, provide power, and support agriculture and drinking water provisions. However, each one is a testament to the unique water needs of the region it serves and an echo of the challenges faced in its creation. To give you an idea, the Folsom Dam was brought to life in the 1950s, serving a dual purpose: flood control and water storage. This reservoir feeds the thirst of industry, agriculture, and the urban areas of the Sacramento Valley. Yet, unlike Chimney Hollow's focus on environmentally sensitive construction, Folsom Dam's story was one of adapting to changing environmental concerns. The installation of a temperature control device years after its completion, for instance, aimed to ensure the survival of downstream fisheries. Then there's Arizona's Glen Canyon Dam, standing tall since the 1960s as part of the colossal Colorado River Storage Project. While it also provides water and produces hydroelectric power, a significant and controversial shadow was cast on Glen Canyon. Its construction led to the submersion of the namesake canyon, triggering an outcry from environmentalists. Now, let's hear out the opposition, too. The reservoir project has faced criticism from environmentalists and other stakeholders who express concerns mainly regarding...
Yes, there's always pushback when it comes to construction of huge infrastructure projects like this, especially like a dam. I mean, it takes a huge space and it literally changes the landscape of that particular area. And I'm sure that there will be people who will be directly and indirectly affected. Usually the biggest pushback comes from environmentalists because of the preservation of nature. Yes, they've justified reasons for such pushbacks because there's some things that should be preserved, be it some type of plants which are native to that area, animals, and just keeping that biodiversity flowing. But on the other hand, in an area like Colorado, where they are facing droughts year in, year out, I think there's a justifiable reason to construct such a dam for water storage for future use. But I don't know, it's one of those things where you can never get it right. Something has to give in order for something like this to proceed and build such a monumental structure in an area like this.
Who express concerns mainly regarding the potential ecological impacts and water resource management. Critics argue that constructing the Chimney Hollow Reservoir will lead to significant alterations to the landscape and natural habitats, potentially displacing various species of flora and fauna native to the area. They fear that, in the journey to quench the thirst of thousands, many delicate wildflowers and gentle creatures may lose their shelter in the process. They also highlight the potential strain that transferring water from the western slope to Front Range communities could have on the Colorado River. Arguably, reducing the flow rate can cause additional issues for ecosystems and populations downstream. An alternative proposal surfaced that greater emphasis should be placed on water conservation and sustainability practices. They believe that more efficient management and reducing waste could help meet growing water demands without resorting to large infrastructure projects. Despite the fact that the project developers have proposed mitigation plans to address these concerns, critics doubt if these efforts will be adequate to offset the possible repercussions. The reservoir isn't just a mechanical masterpiece, though. It brings much more to the table. Once the construction dust has settled, the project will unveil a shiny new recreational area enveloping 1,600 acres, transforming the local landscape into a paradise for fishing, boating, and hiking enthusiasts. The project promises to contribute to maintaining healthy rivers and streams in the area, supporting local ecosystems and species. In essence, the Chimney Hollow Reservoir promises to be a game changer for future generations. This $500 million project is a testament to innovative and sustainable water management. This reservoir is an excellent example of how human ingenuity, collaboration, and sharp focus on benefiting not only individuals or communities, but also the environment as a whole can lead to changes that are long-lasting and beneficial. Are you convinced that it will quench the thirst of northern Colorado's population? Or is there any weight in the opposing arguments? Tell us in the comments below. Thank you for watching, and please do like, share, and...
Yeah, there you have it. This was an interesting video. The work that was put into designing this infrastructure is quite fascinating. It's not easy. Lately, I've been on site and supervising some construction, and just working with the contractors and seeing how they deal with the scheduling and the preparations and the execution of the plans that we design. It's quite interesting, and it's not easy at all, because one thing that I found out is nothing ever really goes according to plan. So you have to keep on making adjustments on the go. So a lot of quick reaction, a lot of proactive thinking, and sometimes there are unknowns that you come across where you have to be reactive to some situations, but you have to be a fast thinker if you're a project manager and you're working on site. And I cannot even begin to imagine for a huge project like this and a huge site like this, where you have all these targets and you have a lot of movement going on site, all the big machines, all the different areas. Because a dam is not only the dam structure, there's construction of the spillway, divergence tunnels, and the landscape around it, and all these things have to be put into consideration during planning. Then no matter how much you plan, there's always something that will come up. I hope you enjoyed this video. Please leave a like and subscribe to the channel. I will see you on the next one.